So in this question here, we need to fully simplify this expression here. We've got 6x cubed y to the minus 2 plus 9x to the 5 in brackets divided by 3x squared y to the minus 3. Now there's two ways we can do this, so I'm going to show you both ways. First of all, we can write this out as a fraction. So we could have 6x cubed y to the minus 2 plus 9x to the 5, and write that as one big quotient, 3x squared y to the minus 3. Okay, now what we can do here now, we can split the fraction. So as we've got this in our numerator, we can split it into two fractions. So now we've got 6x cubed y to the minus 2 over 3x squared y to the minus 3. And then I've got 9x to the 5 divided by this one. So 9x to the 5, 3x squared y to the minus 3. Okay, so now what I can do is, with like terms, I can use the power laws, so the indice laws for each expression. So I've got x cubed divided by x squared. So therefore it's 3 minus 2, which gives me 1. And I've got 6 divided by 3, which is my coefficient, that's 2. So I've got 2 gives me x to the power of 1. And I've got minus 2 minus minus 3. So minus 2 minus minus 3 is minus 2 plus 3. So therefore that's going to give me y to the 1. Okay, so that's simplified. And then here I've got 9x to the 5. Well, my coefficient is a 9 here and a 3 here. So I've now got 3. X to the 5 and x squared. Well, 5 minus 2, that's giving me 3. So that gives me x cubed. And I've got no y term, but a y to the minus 3. Now what I can do is here, as I've got y to the minus 3, I can bring that up to the top and write that as y cubed. So that's going to give me y cubed. Now the reason I've got that is because simply I've got 1 over y to the minus 3. So I can rewrite that as y cubed, because that's what we've got there, it's the reciprocal. And the same here, y to the minus 2, y to the minus 3, I could rewrite that one. That's equivalent to y cubed over y squared. So each one of those I could take the reciprocal of in turn to give me that, and that's going to give me my y. Hence I've got y to the power of 1. So the 1 powers and the indice I don't need. So then that would be that term there simplified, and that would take care of that. Now the other way I can do this is I could do 6x cubed over y squared using that indice law that I showed you here, and then plus 9x to the 5. And then I can do, what I can do here, I can then divide that by this term here, 3x squared over y cubed, again using that indice law. Now what I can do is now I can flip this term here and do multiplication. So now I would have 6x cubed over y squared plus 9x to the 5, still in brackets, and multiply that by y cubed over 3x squared. So basically I'll flip that and change it to a multiply, and then this will be apparently still the same. So now what I could do is I could just multiply each one in turn and with this one here, and then see what my addition is at the end. So 6x cubed times y cubed, I'll have 6x cubed y cubed, and y squared times 3x squared. So I write that as 3x squared y squared. That's a fraction. Okay, so that's that bit multiplied. And now I'm going to add 9x to the 5 times this. So I've got 9x to the 5 y cubed, and nothing on my denominator because I could just simply put a 1 there. And then I've got 1 times 3x squared, which is just 3x squared. Okay, so now using my indice laws, I can just cancel out what I need to do. So coefficients, 6 divided by 3 is 2, that just becomes a 1. X cubed divided by x squared, that's just going to give me x to the power of 1. Y cubed over y squared, that's just going to give me a power of 1. Then here, 9 divided by 3 is 3. So that's a 3, that's a 1. X to the 5 divided by x to the 2 just gives me x cubed. And then y cubed, that will stay. So now I can rewrite that. 2 times x times y. 2xy. And then here I've got 3 times x cubed y cubed. Okay, and we've got equivalent answers on both sides. And that'd be a good place to stop.